On January 31, 2008, the Navy's Office of Naval Research successfully conducted a record-setting firing of an electromagnetic railgun at the Naval Surface Warfare Center in Dahlgren, Virginia.
Right now, scientists and engineers are working diligently around the clock to develop a gun for the Navy that can fire a projectile at nearly Mach 8. That's right, almost 8 times the speed of sound.
Dahlgren in Virginia is home to the Navy's 8 megajoule electromagnetic railgun. By the end of 2007, the Navy plans to start working with a prototype that is 4 times more powerful.
Arm, 3, 2, 1, fire.
The high voltage is created by charging up a bank of capacitors. When the bank of capacitors discharge, a surge of current creates a massive magnetic field. This accelerates the metal projectile to mind-bending speeds. The Navy's goal is to develop a 64 megajoule electromagnetic railgun by 2016. That's 8 times more powerful than this prototype, reaching projectile speeds up to 5,000 miles an hour.
Basically, one ship offshore will be able to cover an arc of essentially 400 nautical miles in diameter. So you could essentially have the Special Forces guys on one side of the battlefield and a major operation on another side, and we'll be able to cover all those with one gun, one ship.
This technology is so impressive that the Navy's actually planning on developing rounds that don't have warheads.
A railgun works off the principles of a homopolar motor. An electric current runs down the rails and across the armature. Current flowing in a wire creates a magnetic field around it, a region where a magnetic force is felt. This force has both a magnitude and a direction. In a railgun, the 2 rails act like wires, with a magnetic field circulating around each rail. The force lines of the magnetic field run in a counterclockwise circle around the positive rail and in a clockwise circle around the negative rail, so the net magnetic field between the rails is directed vertically. The projectile experiences a force known as the Lorentz force. The Lorentz force is directed perpendicular to the magnetic field and to the direction of the current flowing across the armature.